Here is another example, whether the series converges or diverges. In this one, we're going to learn a new method called limit comparison test. What does it say? Suppose we have an and bn, two different series. Both of them are positive terms. This is really important. The limit comparison test works only on the positive terms. If we can find the limit of an by bn, the general term of the first term, divided by the general term of the second term, limit n approaches to infinity, and you find that L is the limit. If this L is a positive number, any positive number, okay, then both the series converge or diverge together. What does that mean? If you know about any one of them, for example, say you know about Bn, it converges, then automatically An converges. If Bn diverges, then automatically An diverges. So what is the main goal here? So to use this test, suppose we have a given series. The general term of this is 5 plus 2n by 1 plus n squared power square. You need to come up with another series, Bn, and we don't know the general term of that. So we know about that series. Okay, is it convergence or divergent? We already should know about. Then we find this limit. If we say that limit is positive, then we can claim about our given series, which is say sigma an. How do we do that? This comes a lot with practice, but there's one small clue. Let's say here the power of the numerator is 1 and the power of n in the denominator is n squared squared, so n4. 1 n power 1 by n power 4 is basically 1 by n cube. So that is my clue for Bn. I'm naming Bn as 1 by n cube. Let's see if it works. You need to find limit n approaches to infinity of an by bn. Limit n approaches to infinity. What is an? 5 plus 2n by 1 plus n squared power 2 divided by 1 by n cube. What happens when two fractions are divided? The denominator one flips. So this can be written actually as 5 plus 2n times this n cube is going to flip and multiply here, divided by 1 plus n squared square. Okay. Now all we have to do is somehow find this limit. I can, before even I do that, I can distribute it inside. 5 n cube plus 2n power 4 divided by 1 plus n squared power 2. Now, you guys have to notice what is the highest power of n. You have to find this limit. For that, we have learned this method in Calculus 1 also. What is the method? Find the highest power of n in the denominator, which is n4. So you're going to divide both the numerator and the denominator by n4. What does that basically means? That means dividing all the terms by n4. So let's do that. Limit n approaches to infinity. 5n cube by n4 plus 2n4 by n4 divided by, here in the denominator it's a little tricky because it's 1 plus n square square. When you're dividing by n4, when it goes inside the square, it looks like square. Okay. When I simplify this, you guys notice that n cube, 3 factors of n will cancel, only 1 factor of n will be left. Here all 4 factors of n will cancel. Here all 2 factors of n will cancel. So let's see what we have. 5 by n. 5 by n plus 2 divided by 1 by n square. Now we know n is approaching to infinity. That means we know from our calculus, limits of calculus, that if x is approaching to infinity and limit x approaches to infinity of 1 by x to the power n is approaching to 0, right? That means this should go to 0 and this should also approach to 0. So what are we left with? 2 divided by 1. square, which is 2. We found this limit. This is what we were calling L, okay? And this is a positive limit. If L is positive, we claim that the given series, which is sigma AN, and the new series, which we claimed sigma BN, they converge or diverge together, right? But what do we know about this one? This one is P series with P is equal to 3, which is more than 1. Therefore, this sigma Bn converges. Remember, P series converges only for P more than 1. Therefore, this converges, and because they converge or diverge together, we know Bn converges. Therefore, we can claim that our given series, sigma An, which we can also write as 5 plus 2n by 1 plus n square converges.